Hello, welcome back. So today our target is a very simple reaction, two reactions basically. So hydroxylation and oxidative cleavage. Okay. So the reactions contain the reagents, namely cold alkaline KMnO4 and hot alkaline KMnO4. I know, like me, many students like they generally get confusion in the KMnO4 reactions, the cold ones and hot ones. So what to do where and what is syn, what is anti, when is racemic formed, when is meso formed. Let's end this confusion today, okay? So let's be very clear on the concept today, and then let's solve very few questions, okay? And I'll try to make any like only questions video on properties of alkenes because we have very important reactions here. Okay, so let us see hydroxylation. Now, what is hydroxylation? What does the name suggest? Some hydroxylation. Somewhere hydrogen is forming along with oxygen. Hydroxy group is adding, OH group is adding. Very simple. So, hydroxylation means an alkene is turning into a glycol. Means two OH groups are forming here. Okay, two OH groups are getting added here. So, this is hydroxylation reaction. Very simple. Now, the catch here in hydroxylation reactions is where the complexity of the question is there. So, the complexity of question lies here, the syn addition and anti-addition. Okay. Now, there are few reagents which we do the hydroxylation reaction. So, the major questions we are going to see is cold alkaline KMnO4, or it is also called as Bayer's reagent. Okay. So, it is called Bayer's reagent. Very important reagent. Bayer's reagent. And we also have osmium tetroxide in ether. Okay, osmium tetroxide also we can also use. So what is here? Like this in case of pyridine also. Now, when you are using these reagents, Bayer's reagent or osmium tetroxide or I2 in place of CH3, COAG and anything like this, so syn addition takes place. What is syn addition? Syn means the same side. Now the glycols means two alcohols, one two alcohols are called glycols. Now, when there are these two OH groups are attached from the same side, stereochemically you think. Now they are attached from the bottom like this from the same side. Then syn addition, we are going to call them syn addition from the same side. If they are going to attach in opposite sides like this, one from up and one from bottom, then it is called anti-addition. So these reagents, whatever you can see here, the Bayer's reagent, the osmium tetroxide in ether, or I2CH3COAG in NaOH, or these all perform syn addition. Now HCO3H means peroxyformic acid. In case of peroxy acids, means what is peroxy? Where an oxygen-oxygen bond is there. In such kind of acids, anti-addition takes place. Okay. So the main catch here, very important point is Bayer's reagent and osmium tetroxide and peroxy acid. Syn addition takes place and here anti-addition takes place. Okay, very simple. Now let us see few examples. Now in osmium tetroxide or pyridine, what is happening? OH and OH are going to add from the same side. Or what is Bayer's reagent? Cold alkaline KMnO4. Like we also have hot alkaline KMnO4, but Bayer's reagent is cold alkaline KMnO4. Very important. Cold. So cold alkaline KMnO4. So whenever you are going to react the alkene with cold alkaline KMnO4, or it is also called Bayer's reagent, then syn addition takes place. Means OH and OH meet from the same side. And if you are going to use osmium tetroxide in case of pyridine, then also syn addition takes place. Now let's see this racemic and meso confusion. Many questions are based on this racemic and meso compounds. What? So we have seen in stereochemistry that there are two different kinds of compounds: racemic compounds or meso compounds. Racemic mixture basically. So racemic mixture is a mixture of two different optically active compounds. So what happens is one optically active compound is going to rotate the PPL, the plane polarized right to one side. let's say right, then the other will rotate to the left. So because of this external compensation, one is rotating to the right, one is rotating to the left. It will show no net optical activity. That is called racemic mixture. What is meso compound? Because of internal composition, one chiral carbon is showing one uh, configuration, and another chiral carbon is showing another absolute configuration. So because of internal compensation, the compound is becoming optically inactive. So because such kind of compounds are called meso compounds, and this mixtures are called racemic mixtures. Now the catch comes here. Now they in exam they'll give cis alkene or trans alkene. They're going to give you these reagents, the syn addition reagents or anti-addition reagents. And they are going to ask what is formed, a meso compound is formed or a racemic mixture is formed. How do we find it? So there is a small shortcut for this. I'll tell you in the last page, okay? Here. Okay. The shortcut for KMNO4 or Bayer's reagent. So what is it? It is car. Car. So car is the shortcut. Just remember car, then all your answers will be solved. Means what does car mean? Means a cis alkene. A means anti. Anti-addition forms a racemic mixture. And now in this acronym, you are going to change any two positions. Then the third position is going to remain same. Now let me give you an example. Now let me take transalkene. If I am taking transalkene, then I have to change anything other one. Means I will take a syn addition. Then the racemic mixture will be same. So when I will take transalkene and do syn addition, then racemic mixture will be same. Now, if I'm changing transalkene, I'm remaining transalkene the same, I'm going to take transalkene, but I'm going to do anti-addition. So if I am doing anti-addition with transalkene, now I have changed one. Then I have to change another one, right? So two should be changed. R will change to M. Racemic mixture or meso compound will be your answer. Okay. So here it will become meso compound. Yeah. So whenever a transalkene is undergone anti-addition, then a meso compound is formed. Now, if I take cis alkene and do syn addition, what would happen? I have changed cis addition. Only one I have changed. So I have to change R. It will become N. Whenever I do cis alkene syn addition, then a meso compound is formed. Okay. So if you are going to change two, then the third one is not going to change. That's the trick. Now, and again, if I take cis alkene with anti-addition, then racemic mixture is formed. Just remember the car, then you will get all answers by itself. So why is this happening? Why is meso compound is formed? Why is racemic mixture is formed? Let us see. Okay. Mm, yeah. Where are we? Right. I wrote them here. Cis al car CSM TAM TSR. Okay. You can see here. Now I have taken this cis alkene here, as you can see, and I am doing some syn addition. Then glycols are added at the same position, right? Like at the same side. Then what will be the enantiomer? Same side OH should be there. Same side OH should be there, right? So only one compound is formed. Same side OH should be there. If I draw another compound like this, these both are same, right? So only one product is formed, and you can clearly see one will be R and another will be S. So it will be a meso compound. So cis alkene, syn addition, meso compound is formed. That's why we named it CSM. And if you do the opposite one, anti-addition, then two compounds are formed. Two compounds are formed means what would happen? Racemic mixture will be formed, right? So means in the alkene, OH will be formed like this, or OH can be formed like this. We are going to give importance to stereogenicity, like where the OH group is present. Okay, and again transalkene, I'm doing syn addition. Okay, sorry. Transalkene, I'm doing syn addition. So I know that car is there. Transalkene syn addition, I have changed these two, means it need not be changed. R. So racemic mixture is formed. So syn addition means OH are going to be on the same side, but CH3 are on the different planes. So a racemic mixture is formed. Very simple. So if any question comes based on the cis alkene, trans alkene, syn addition, anti addition, you are going to rock it. Believe me. Now we have test for unsaturation. Now, right. So this test of unsaturation is for identification of alkenes. We have two tests of unsaturation. This is used for identification of alkenes. Okay. Now what is this? You are going to take KMNO4. KMNO4 is generally in purple color, right? So you are going to react it with some alkene or any compound you don't know. Then MnO2 is constantly being produced. So MnO2 is generally brown color. Okay. So whenever you are going to use Bayer's reagent, MnO2 will be the byproduct. Okay. So because of formation of MnO2, the solution becomes brown in color. So if it is forming brown color, then alkene is formed. Very simple. Right. So alkene is formed. Mechanism is not important for all these addition reactions. You can just remember. And then another test of reaction is, test of unsaturation is with bromine water. So bromine or CCl4 water also. You can do anything. So alkene with Br2 water, generally it is in brown color or deep red color or deep red in color. So whenever alkene is going to react with this bromine water, then this red color becomes colorless. Colorless. So then you can tell that alkene is there and unsaturation is there. Okay, that is it with hydroxylation reactions. We have seen all the syn addition reaction and anti addition reactions. So these reagents are very important. You have to remember them. Bayer's reagent means cold alkaline KMNO4. Cold alkaline KMNO4 is Bayer's reagent. Bayer's reagent is cold alkaline KMNO4. Just remember it like anything. Okay. Osmium O4 is also a very famous this thing, and generally it happens in H2O because of protonium ion is formed. This we can discuss in the mechanism, but mechanism is not important for this. Okay, right. And then cold alkaline KMNO4 is Bayer's reagent. Bayer's reagent forms glycols. Remember this. Okay. Now let's see hot alkaline KMNO4. Now till now we saw with cold alkaline KMNO4. Now it's time to discuss hot alkaline KMNO4. So this is called oxidative cleavage. Why is this reaction called oxidative cleavage? Let us see. Okay. Now, oxidative cleavage why means because whenever alkene is going to react with this hot alkaline KMNO4, so whenever it reacts with hot alkaline KMNO4, then in presence of this, an acidic hydrolysis takes place. So, acidic hydrolysis takes place means uh, a high chance of oxidation takes place means really like many times the oxygen is being added. Now what would happen because of this, various products are formed for the given alkene. Now for example, these are the examples, these you have to remember. Okay, now for example, there is a terminal alkene like this, double bond CH2 at the end. Whenever there is terminal alkene like this, then it would immediately turn into CO2. Okay, it would immediately turn into CO2. Now if there is a middle alkene like this, alkene like this, if it is like this, then what would happen, just an oxygen is added in case of this double bond, a ketone is formed. And if there is an alkene in middle of the chain like this, then a double bond O along with OH is formed. Okay, first let's see, two oxygens are added, then one oxygen is added with along with an OH, and now only one oxygen is added. Okay, these are the important changes we have to keep in mind. Now let's see an example. For example, this is the alkene given to us. Whenever we are going to react it with hot KMnO4, what would happen? First, this is going to break. Oh, this is going to break. And what did I say? When there are two alkyl chains like this, then just keep a double bond O. Means a double bond O is going to come like this. We have seen a reaction like this just before, right? In the previous video. Okay. and and what would happen? This, if there is a middle, alkene is in middle, right, for this. So if alkene is in middle, what would you do? A double bond O is formed along with OH. Okay, so a carboxylic acid is formed here. Now, in case of phenol, you can clearly see here the alkene is targeted. So a double bond O is formed. A terminal alkene is formed, then CO2 will come out. Okay, and H2O is also a byproduct here. So this is the reaction with hot KMnO4. The things we have to remember is in cold alkaline KMnO4 or Bayer's reagent, we also use OSO4. What is glycols are formed means two OH groups are formed. That, sorry, not also not that's called hydroxylation. So we have seen syn addition and anti-addition reagents, racemic mixture and meso compounds, and then we are having hot alkaline KMnO4. In case of hot alkaline KMnO4, various products are formed: terminal alkane CO2, middle of the chain, then double bond O and OH, and if we get a 3-degree situation, then only double bond O. That's it. So we are done with all the important properties of alkenes, and we have some named properties and then rest of the reactions which we will be covering in the next video. Thank you for watching till here. Have a nice day.